has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information and that association to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital of people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole.
Hello, and welcome again to Automate Live. We are in this third day of Automate 2024 here at McCormick Place in Chicago. I'm your host, I'm Jana Martin. I am the Media Production Manager for the Association of Advancing Automation, and we are so thrilled to be throwing, once again, the largest automation event in North America here at Automate. Thank you all for being with us this week so far here in person as well as online. We're really excited for another full day of programming here on the Automate Live desk as well as at the actual show. Don't forget, there are still many conference sessions. You can come and get a day pass. Check that out. We have the Engelberger Awards tonight. Unfortunately, those are already sold out, but we're really excited to honor 3 robotics geniuses tonight with the Joseph F. Engelberger Award. And we're going to have one of those winners joining me at the desk right after this intro. So stay tuned for that. Coming up on the desk also today, we're really excited for the first time in Automate Live history to be featuring an interview all in Spanish for our A3 Mexico friends. So we're really excited to feature Claudia Sofia Rodriguez on that panel. Stay tuned for more. Tomorrow we've got NVIDIA, AMD, Jeff Bernstein, and many more interviews. So stay right here for Automate Live. Thank you for tuning in. And if you need more info about the show, any schedules, including this schedule, you can go to automateshow.com and please follow Automate Show everywhere. Thanks, and we'll see you soon.
had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information and that association to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital, the people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole. has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information and that association to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital, the people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole. has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information, that association, to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital of people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole. has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information, that association, to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital of people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole. A3 has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information and that association to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital, the people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole. has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information, that association, to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital, the people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole.
What I'm holding here is a piece of history. It was written in 1974-75 time frame by my predecessor, Bernard Sallet, and really is a roadmap for how we've grown to be successful from a very early start with not a lot of financials to a very successful trade association.
Hello, I'm Bill Shatner, and I've been learning about robots. Yes, robots, and particularly about the very important part they play in industry. And we'll begin right over here with a robot that meets the most often used and very official sounding definition of industrial robot. Are you ready for this? Industrial robot.
Hi, would you welcome Joe Engelberger? We can program the machine to do a commercial.
The list of tasks that industrial robots can do and do superlatively well is growing all the time.
The World Robot Conference. The event has become the biggest and the most international.
There's so many more applications in so many more industries that we've never seen before.
What about the future for automation? There seems to be no limit. Perhaps automation can lead to a better life for all of us. I know what I think. How about you?
So, can you believe it? 50 years of A3?
It's amazing. You think about 50 years and it sounds like a big number, but it went by so fast.
It really did. I mean, I'm amazed at how quickly 50 years goes by.
Yeah.
You know, it's like crazy that we're here this big of an anniversary. What was it like for you when we broke away from SME? That had to be terrifying.
It was a big decision on my part. With a family and a future I thought I had at SME, I wasn't sure in the beginning, but something told me this could be a good thing. RA started in 1974. It was a struggle in the beginning. There was a technical group within the Society of Manufacturing Engineers dealing with robotics and automation. SME being a well-known large individual member society, took on the task of identifying robotics as a future business. We ended up with a meeting in Detroit in a smoke-filled room with about 7 or 8 competitors, companies like Unimation, IBM, Bendix, and General Electric. These were guys that never met before. It was the formative stage of getting the association established, and the father of the robotics industry, Joe Engelberger, finally came on board, and we started the association. Thanks to SME, they put up some seed money and staff, and we officially separated in 1983, and that's when I became the head of RA staff.
Don was a tremendous leader. He put together a great team of people to start the association.
Don was the person with the vision for the Robot Industry Association and then subsequent associations. Don was a master communicator, connecting up the RA with its partners like the groups in Japan, the groups in Europe, groups in US to work together for the benefit of the industry.
If they can get in a room and share some of the struggles and accomplishments that they've had over the years, you learn from that. It really did provide a home for an industry that was, very young in its beginning, but now is mature and see all kinds of things moving towards automation and robotics that might not have been foreseen, 50 years ago.
When RIA was formed and robotics was supposed to be the next industrial revolution, there were a lot of robots being purchased by the automotive industry. They were the largest end user customer. Shortly after, they canceled a whole bunch of orders. Whether they were dissatisfied or whether they couldn't find the right applications or it was too complicated.
People just completely weren't aware of what they were, what they could do, and the right way to use them. The skill set among the people who might support them wasn't really developed at that time.
Ultimately, that led a lot of robotics companies to exit the industry. And that was a major challenge for our trade association. And a lot of people doubted whether the industry would be able to survive.
Through the efforts of the RIA and the member companies, slowly the technology became better known, and it started to find uses in other industries in other ways.
We launched a machine vision association in 1984. Over the years, we added several other associations on motion control and artificial intelligence.
It brought together all of the different supplier companies which could deliver the technology. Both the companies that would provide the human capital, the people that knew how they operated and could work with them, and then also the companies that physically made the robots themselves. People would begin to understand that they could make their businesses operate more efficiently and more effectively using robot technology.
We did some major things like getting industry to report their statistics every month, and it became a benchmark for the industry to be the source for those business statistics. The idea of moving from hydraulics to electric motor robots, and that really was a technical breakthrough for the industry. And more companies came in and developed new robot equipment doing new applications.
We're the largest trade association in the world focused on robotics, machine vision, AI, motion control, and related automation technologies. That's our sole purpose in life, is to encourage companies to adopt these technologies and teach them how to do that successfully. I remember when we talked about merging the separate associations under one umbrella. And it took us some time to get there, to get to this one A3. From my perspective, it's ultimately worked out that, we're larger than we've ever been. The fact that companies can join just one entity now, and I think that's really allowed us to bring in, big companies like Microsoft and Google and Intel and Amazon. You've got to be pretty proud of the legacy that you left and the way the organization has developed, I hope.
Yeah, very much so. Extremely happy to walk through that Automate show and just say, oh my gosh, look at the size of this.
I think one of Jeff's greatest accomplishments has been the reshaping and reforming of the Automate trade show. The robotics show has been around for decades. Frankly, to a point it was getting stale. We were starting to lose exhibitors. It was at a point where there was actually some proposals to sell the show or cancel the show, and Jeff vehemently disagreed with that approach. But to his credit, he not only disagreed with it, but he doubled down and put his energy and effort into it, and led a whole team that totally reshaped the Automate show to make it what it is today, which is one of the best shows literally in the world for factory automation.
We've gone from approximately 40,000 square feet to pretty close to 400,000 square feet. We've gone from 3,000 attendees to over 30,000 attendees. It's been quite a remarkable turnaround.
Jeff has tirelessly worked to promote the industry and to further the industry, to get robotics and automation noticed on a global stage.
We opened a A3 Mexico office. We became active in China. We've grown the association significantly. We're up to 1,280 company members, I believe. We've got so many good people, so much talent, and I'm very proud to lead this team.
I don't think that there's an organization that's having a bigger impact on increase of productivity, on creating jobs through automation than A3. It's an organization that creates tremendous network. You talk to other A3 people, they'll tell you some of the best friends they made in their life were at A3.
The biggest thing that A3 has been able to do is that it's made automation accessible for anyone, providing education or simply by connecting people with the right people to make that successful application happen. I think it's just incredible to see how much has been achieved in the beginning by a few and is now being achieved in such bigger ways by so many.
The legacy of A3, I think right now is a bit undetermined, but when you see the response to the trade show and the membership growth and the new activities and the investment that the association can make in the future in an industry that wasn't really supposed to be an industry in the beginning, I'm happy to say that for me to sit back now and watch what's grown to be a viable trade association is a big accomplishment
I think about that number, 50 years, how long this association has been around, and I think about the impact robotics and automation have had on industries like manufacturing and logistics. And then I think about what's happening today. Application of robotics and AI are going to help solve problems like finding cures for rare cancers, helping improve the environment, and dealing with issues related to hunger and affordable housing. It's going to transform our lives for the better. And that's where A3 comes in. And we're just getting started.
A3 has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information and that association to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital, the people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole. has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information, that association, to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital of people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole. has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information, that association, to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital of people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole. had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information and that association to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology, the human capital of people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole. has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information and that association to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology, the human capital of people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies.
All right, good morning, everyone. Welcome to day 3 of Automate Live. I'm Jake Hall, the manufacturing millennial. Today we're going to have an amazing conversation on how companies are leveraging new technologies into new industries to solve problems. Now, I'm here talking with John Carroll. He is the sales manager for the Americas at SMW Autoblock. How are you doing today, sir?
Doing well. Day 3, feeling good.
Yeah, I mean, it's been a packed week so far.
It has. We've got a nice amount of traffic and great discussions. Enjoying the Chicago culinary experience every day is a new experience. So.
You know, and the atmosphere has been absolutely amazing.
Super.
Seeing a lot of people who are excited to solve problems in the industry. Mm-hmm. It's been a lot of fun. But I want to learn specifically how SMW Autoblock is solving problems. So for the audience that doesn't know, could you give us a background about the company?
Sure. So SMW Autoblock may be new to the automation world, but we're not new to, for example, CNC manufacturing.
Yeah.
We are an established entity there, and we've been there for many, many years. I mean, we're in a European company based in Turin, Italy. Mm-hmm. What is not known, we actually acquired companies in Germany. So we're almost like, it's a funny dynamic.
Yeah.
We've got an Italian headquarters and a German technology center. So I always call it the pizza beer connection. So,
which is a good combination to have.
And it's always good when they talk technology because they're always fighting. The Italians are very passionate, and the Germans are very sure, and it brings a lot of energy in there.
Absolutely.
But it's two cultures. But you know, we've been in the CNC industry for a long time. Work holding stationary work, holding chucks. We're a market leader in a lot of industries and where we sell into. We have established relationships with a lot of players in industries such as your Mazaks, your Akumas, DMI Moris, and they see us as a partner.
Yeah.
But of course, like I said, you know, the trends in that industry is moving to more automation, machine tending. A lot of things are moving in that direction. We never jumped on that bandwagon early because we were really happy with where we are. But you know, times are changing, and we have to be on that trend. So we made the commitment, and we invested the money to develop, solutions for automation, especially in machine tending and for CNC automation, but they translate into a wider breadth of industries.
Absolutely. And I think that really reflects well with your background. So you've been in the industry for 18 years, and you've actually then lived in Germany for many of those years. You were over there, you served over there, you worked on helicopters overseas. So you come from a technical maintenance, understanding how things work background. And I think the highlight of that as well is when there are problems that are happening in the industry, you're able to then work directly with that German engineering team.
Yep.
You know, so what's been that experience like, you know, going back and forth and communicating problems right back to the engineering team?
Yeah, it is. It's a definite advantage because, like I said before, you know, if you work for a German company and you basically are here stationed, they don't understand the American kind of mentality, and the Americans don't understand the German mentality. I'm almost like a bridge in that relationship, so I can interface directly with the engineering over there, talk to them about the application, tell them what it is there in a way that they understand it, and it actually speeds a lot of the process going forward. And of course, it's comfortable that for them speaking in their own native tongue, engineering that deep with me, and then of course I take that, interface that with a thing. So in a way, that's kind of my special sauce to kind of discussing that, and it brings a lot of value. And that's why they kind of like they enjoy engaging with me. They have a lot of hesitation talking to an American customer directly. Once I kind of sit in the midst, they feel a little bit more comfort level.
Absolutely, you know, they feel like you're blending in a little bit better when it comes to stuff like that. So one of the new technologies that you guys I know are pushing recently is your inductive coupler technology.
Yes.
Now, it makes sense. It's been in the machine tending industry for a long time, right? When you're doing tool changes or you're replacing all your work holding devices, a lot of times you're automating that work holding device, so hey, it can come in and can come out. You don't need to have an operator manually, cranking and opening down the clamps. But you're pushing that now into the automation industry, the robotics industry. Can you talk about what that transition was like and what you're doing in this space?
Yeah, I mean, when people think about work holding, everybody thinks about jaws and chucks and they're dumb and everything like that. It's not the case. It's becoming much more, we need a lot more sensors in there because we're holding work pieces that are much more more fine, like especially industries like aviation and medical. It's not a big block of metal anymore. It's you've got to make sure that you're putting the right amount of pressure. Therefore, we have to integrate sensors. Now, how do you do that on a rotating platform at 2,000 RPM? And you've got to power the sensor, and you get the feedback. So that's where the solution of the inductive coupler came in, and that's where we started developing a whole family of products in regards to that to solve our problems. How do I give that feedback to the the CNC machine to basically make sure that it's holding it at the right pressure. That was the impetus for this. But the thing is, developing it for that industry, you see a whole range of other applications. I mean, slip rings are established in there. I used to sell slip rings many years ago, and they're a great product. But the inductive adds a dimension where I can basically seal that up. IP protection is really high. Vibration is not an issue, and I can basically, have a certain offset. That it doesn't have to be exactly set up correctly, and that's something that's really key. And the form, fit, function factor of that, I can basically change the shape, whether it be a threaded to a ring style, or I can make a ring with a receiver end. So there's a lot of variability of how to actually place it on the machine, which gives a lot of flexibility to customers that are like, oh, I have to solve this problem. How do I bridge that gap? And it's and that is like that special sauce where we saw for our own needs to solve that problem. Now we can translate it into a wider industry that are looking for it. For example, end of arm tooling. Right. Biggest problem is cable management. Imagine if I had an inductive coupler on the end of there where instead of 270 degrees that I can go past that. It gives a lot more flexibility. Another application in robotics is, quick changers. You got the nice little mechanical pins on there that wear all the time, which, we do a lot of tool changing, especially on our applications for machine tending in-house. We saw that issue and said, we're replacing these all the time. Why not put an inductive coupler there that never touches, never wears, and that's basically solving a problem for us. So.
And I remember that when I was doing some machine design back in the day and we had rotary tables. It was a nightmare to get consistent, connectivity on devices, even if it's through power, if it's communication, if it's I/O, if it's some kind of protocol. There's a lot to it when it comes to when you're not using inductive coupler, but I mean, this would have been 5-6 years ago when I first experienced, probably even more than that, really started seeing inductive coupler technology. It's really simple now. And I think before sometimes it might have been a little intimidating because you're like, okay, how does this work when it's communicating wirelessly? There's risks to it, but I think the risks have really been reduced in years.
And it's also, the people accept a little bit more because, look, your iPhone is being inductively charged. As simple as that. Years ago when I was selling slip rings, inductive was a fantasy technology, and people were skeptical about it. It's much more accepted today, and the thing is, we're able to perform things like I said. We can transmit Ethernet signals across a 6 millimeter gap without any signal, reductions. I had issues with vibration with slip rings back in the day, and it was, one byte is what it takes to get a messed up signal, and now you can do a consistent signal across that, and that's really good.
Absolutely. So when you're putting these solutions out there, what should either integrators or custom machine builders know about this technology when they want to integrate this type of solution? What are the type of questions they should be asking? What applications should they be looking out for? What's the best approach for integrating this technology?
I think they have to look at it, what they're trying to achieve, first of all. What is the sensors they're trying to mount on there? What is if they're trying to put motors on there? What is the power? Basically, power and signal are our baselines in there, okay? And, we have, a set form of, normal standard solutions that they can basically fit in there. If they can do that, great, no problem. But if there's some challenge with the geometry, is it a different shape? Is it a rotary table? Do they have to get the power and signal transmitted a different way? Is there those kind of concerns? Then we can start having those discussions. Once we have the baseline, then we can have the discussions as would the standard solution fit, or do we have to go a little bespoke on there? Okay. But they have to be, I think, realistic of what they're trying to do within the application, and then we can actually, solve and basically, transmit the power and signal that they need there.
Absolutely. So we look at just general trends in the industry, right? Companies are automating more and more. They're bringing robotics more into the industry. What are you most excited for about when the industry is moving forward, the type of trends and technology that you want to see?
Look, I see a lot of, there's a lot of players, especially a lot of robotics players on the marketplace. We're coming in here as an end-of-arm tool or thing. So, we're looking at, just the wide variety of trends that are coming here, integration of other technology, not only our technology as grippers or inductive couplers, but we're talking about vision that's coming in here. That's always been there. AI, generative AI is going to be a huge trend for us. We're thinking about that also. I mean, just for grippers, we've seen some of what our competitors are doing, which is great stuff, and that's going to drive us into developing better products in the future. But we see a lot of the AI trends as being a key thing. I just see the applications are changing so much. Machine tending where we're based is changing every single day.
Absolutely.
And we see the variations in there, and I mean that's our world, and we have to adjust and change to it. Now, of course, we're stepping into the big world of automation in general.
Yep.
And then we're going to learn from it too. We're going to develop as a company.
Absolutely. So when we're walking the trade show floor here, there's going to be 40,000 people that are walking here.
Yeah.
And you've been in the industry for a long time, 18 plus years. What would you say to this next generation that wants to enter our industry? What were the hints and tips that you would give them around being a part of automation, being a part of robotics, going to join the SMW Autoblock team that's making new technologies to make automation easier? What would you say to this next gen?
Be curious. Sometimes don't do the traditional, educational pathway. I'm a big believer in apprenticeships. I think I mentioned to you.
Yeah, absolutely.
My son did an apprenticeship. That's the way to learn. Get in there on the ground floor. Get your hands dirty, and then develop from there. I didn't take the straight path. I was fixing helicopters. Then I did my master's. Then I started doing other things. The straight path doesn't exist. Be as diverse as possible. Learn things. Ask questions constantly, and be, like I said, be curious.
Yeah.
That's the biggest thing.
Absolutely. So what's next for SMW Autoblock? You guys are pushing out a lot of cool technology. You guys are working in the end of arm space, the clamping space, the inductive coupler space. What are you guys excited for on the next problem that you guys want to go in and solve?
The big problem for us is going to be IMTS, which is the big show down the road. And, we're ramping up for that show. We're going to be showing a lot of the machine tending things. But we also are diversifying. From this show, we're going to be looking at a lot of the customers that are approaching us and developing a lot of new technology, especially on the inductive couplers that are kind of coming on there. The grippers that we're going to be developing are going to be, this is kind of the soft launch for a lot of the products that we're developing. And then at the end of the year, we're going to be having a full product portfolio. But we've got some things in the pipeline that we're really interested in developing. And we want to make ourselves unique.
Yeah. Absolutely. I think that's just the big thing out there. When you're going out there and you're wanting to really solve customers' problems, you can't just be off the shelf. No. You have to go out there and you have to design solutions around the problems that are going. I think that just goes back and relates to you saw a problem in the clamping, in the CNC, in the machining space. And you went out there and said, hey, we got to make tool changing easier, especially when companies want to do more lights out tool changing in manufacturing, when they want to be have more productivity, they want to have more efficiency, they don't want to have the machine tied down to an operator who can attend it next. And then you take that technology and say, well, wait a second, we can now take this technology and then move it over to robotics and machines within rotary tables, areas that we need tool changing on. I think it's one of those things that's how a company goes out and creates change in the industry.
Yeah. And it's about being really open-minded about it and looking at that. And like I said, that's how we're approaching the marketplace. We, with that curiosity. And thinking about what the next trends are and being open-minded to it and having great partnerships with a lot of companies out there and learning from the robotics manufacturers here. We're trying to develop those relationships also.
Absolutely. So John, if our audience wants to learn more about what's happening with SMW Autoblock, where do they find you? Where are some good channels they should be finding you at?
Definitely. Well, first of all, if you're at Automate, come and visit at our booth, 3676. That's the first place to kind of look for us. Our website is a great resource. We actually, it's kind of funny, we set up a small, SMW Autoblock is known, we have all that, but we have a website, SMW Electronics, because it's the products, that we're developing there. So basically, smwelectronics.com. A lot of our products are on there and developed, a lot of information there. Like I said, and definitely at the IMTS, we'll be there showing a lot of more of the machine tending. We have a lot of machine builders that are actually visiting the show today and talking to us. But we'll see it at my IMTS, and we'll have a big booth talking about a lot of things, and that'll show the full capabilities of our company.
Absolutely. So online. You check them out on LinkedIn. Check them out on their website with SMW Autoblock or SMW Electronics. And of course, visit them at upcoming trade shows as well. Or if you're here at Automate right now, there's still time. We're here all day today and tomorrow. Swing by the booth, learn a lot about what's happening in the industry. John, thanks so much for taking some time today to talk. We really appreciate it. Jake Hall, the Manufacturing Millennial. We'll see you guys soon.
A3 has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information, that association, to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital, the people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole.
Hi, everyone. Welcome back to Automate Live. My name again is Jana Martin at the Association for Advancing Automation, and I'm really excited to be back here on the desk now with Zachary Gray. He's the Business Development Manager for Additive Manufacturing at Siemens. Zach, thanks for being here today.
Thanks for having me.
All right, so additive manufacturing, 3D printing, that's your expertise. Let's dive into it. But first, just tell me a little bit more about what is your role and what do you do at Siemens?
So my role at Siemens is kind of very broad. I do many different projects, from financing topics to digital factory planning to supporting different machine builders, but also machine users on how they can use Siemens technology and industrialize additive manufacturing. So going from an R&D environment to a full industrial factory-based machine.
Okay, and so the overarching theme at Siemens is industrialized additive manufacturing. What exactly do you mean by that?
So when people normally think of industrial 3D printing or just 3D printing in general, they think of a tabletop machine.
Exactly.
Some type of a fused deposition modeling machine, a small 3-axis gantry that might sit on your table for prototyping.
Right.
Yes. But we're starting to use a lot of these different additive modalities in general industry. So end use parts, repair parts, still prototyping, that's also there. But from a Siemens perspective, whether it be our hardware or software, we truly believe, and we've proven it out in traditional manufacturing techniques, how you can utilize platforms of our industrial controllers, of our industrial software and platforms that produce a more ruggedized, repeatable process and part and really concept of how you would do those additive manufacturing techniques.
That's so awesome. Now, what would you say is really the biggest challenge with this? Just because, industrial grade additive machine builder, like it's different materials. There's a kind of a different standard there.
Yeah. One of the biggest challenges is definitely understanding where the different type of machine fits. So a lot of people think of a additive manufacturing machine, a 3D printer, as something from like Star Trek, a replicator. It will never do everything for every application.
Right.
You have to understand what build volume it is, what type of material it is. Does it make sense cost-wise? Are you producing a part that is going to be different than how you've been producing it for 40 years? How does that fit in? So a lot of people coming from general industry, automotive, aerospace, large-scale industrial machinery, they're like, well, we know what additive is. Like, yeah, we want to use it, but they don't even know where to start.
Right.
So helping them get to the point where they can even talk to the machine builder or the consultant or whoever it might be, that's probably the biggest challenge.
I can see that. And I mean, just helping people realize, like, you don't have to rebuild the whole entire part. You can use this technology just to fix that part of it that's broken even, which is incredible. Okay, so what additive manufacturing techniques excite you most as an engineer? That's your background. I mean, let's geek out on this. What is so fun about 3D printing?
So it's the sky's the limit type of a thing.
Yeah.
So I guess if I had to pick a modality that I've been most connected to, it's probably directed energy deposition, just from my history.
Okay.
However, we're doing a lot of great things with vat polymerization and binder jetting that really interests me, because it's something a little bit newer for me that I'm kind of dipping my toe into, if that makes sense. I mean, you'll never know everything, right?
No.
Never can know everything.
No.
And from my history, and I come from robotics and machine tool background, there's a lot of synergistic type approaches to those technologies that's similar to how a traditional subtraction mill or robot has been applied there, which makes me, be able to apply that base level knowledge from before to it.
Yeah, can you explain that a little bit more? Like, what are the differences there with the subtractive manufacturing?
For sure. And there's a lot of crossovers too. So
Okay,
you'll sometimes machines aren't just doing 3D printing. Sometimes they're a hybrid application where you print something, you scan something, then you might be taking away some material with a mill, all in the same machine, or kind of separate from that. Now, if you think about a tool center point or how you're depositing that material, there's a lot of ways that you're going to program that and tie in the actual end effector of whatever it is, so a gantry or a robot, something like that, but tie that into the motion profile. So very similar from thinking of it not just as a spindle at the end of it, right? But extruding out some type of a polymer or pushing metal out with a wire and somehow melting it or bringing it to a point where you're manipulating it into a shape.
Very, very cool. Okay, so are the end users of 3D printing, additive manufacturing today mostly emerging new companies or subtractive product manufacturers who have jumped into this new technology, or both? What are you seeing?
It's very broad. Like, you know, I could probably give you examples of very new ones all the way to a traditional manufacturer that's starting to dip their toe in it.
Right.
If you think of composites manufacturing, which let's say it's the most traditional 3D printing or historical, right?
Yes.
A lot of them are traditional manufacturers that see benefits of using this new technology.
Right.
Especially,
you don't have to sell them. They know what it is.
Yes.
They want it.
Yes. And they might have been testing it out for the last 10 years, right? They had it in an R&D facility that they had. They're a large prime or tier one in one of those main industries. They know what they want. They've been trying it. But on top of that, there's a lot of people that come and just have no idea. They've heard additive manufacturing. They might even be a small job shop, right? And they're like, how can I utilize that? How can I have something unique in my world? I've even from a Siemens perspective, I've been using Siemens technology for traditional manufacturing. How can I take some of that knowledge and apply it to the additive space?
And what do you see being that transition point for those who have been thinking about it, and what finally gets them over that edge? And when you talk to that smaller company, what makes them realize, okay, we've got to invest and dive into this because it's going to...
Blank, yeah. I guess the biggest thing about it is they don't want to be left in the dust, right?
Right.
Whoever their competitor might be, they are doing something different that they cannot do.
Right.
They see a benefit for a part that they can manufacture that they weren't able to manufacture before.
Whether that be the design of it, mostly...
How it's actually modeled, material.
Right.
All those different things.
All
And
these details.
that's the cool thing about Siemens. We go all the way from the beginning with software of design through simulation down to actually putting that part program to the machine, and then how you're driving that machine. How are you getting the analytics off of it?
Wow.
Siemens is end-to-end.
Yeah.
We always like to say that, but for that, it's so tight into additive, because if you're not designing it for additive, what's unique about it, well, then just do it how you've always done it, right?
Exactly.
Leverage the benefits.
Actually take advantage, exactly. Okay, here's a fun one. Let's compare your subtractive manufacturing days with today's and tomorrow's additive landscape in machine building. There's a joke going around that says you only need to write the algorithm backwards. Explain that for those that don't understand.
I wish it was that easy, right? that all you had to do is take your part program for what you were doing on a mill that's taken away some material from a block, and you could just write it backwards, and then now it can produce the same part. But it's so much more in depth, understanding the design characteristics of that part and how are you going to build it on those each individual types of industrial 3D printers.
Right.
And it's more than even just thinking about a slicer. So everybody talks about that's a traditional, or not traditional, but it's a used word in the industry.
Absolutely.
About how you're deconstructing the part and layering it, build layer by layer. But it's more than that. You have to actually understand how the energy going into it, maybe the laser, if it's a certain system, how's that going to interact with the part next to it? So.
Oh, wow.
Yeah. So there's a lot of pieces. It's not just hit a button, right? A lot of smarts, AI pieces that can be built in the individual components of a machine. How do you use that to automate the process from all the way from the design to actually printing it and making sure it's the first time right?
I mean, that's something we talk about all week here at the desk, is how is artificial intelligence making all of these processes better in automation. Can you talk a little bit more about the way AI and additive manufacturing, like where do you see that going in the future, and what excites you about that?
Well, because it's so, we like to talk about digitally native. You have to use it on some type of a computer program. You're designing that part and designing how the machine's going to print. Well, if you start to build in automation and true AI capabilities, that can cut down that process, and it can learn from it a lot better than what just one operator, one designer can do. So we're, even at Siemens, got to do that plug or whatever, we have AI capabilities in a lot of our different platforms, particularly our factory automation platforms.
Right.
And we've been applying that with different key machine builders on how to do it for their process.
That's so cool. Okay, so tell us about the various media that are used in additive. Have new doors been opened since additive metal made its appearance in terms of market applications?
So a lot of people think that additive will take away, or the fear, let's say, is that additive is going to take away how everybody's been doing things for 50 years.
People are scared of change.
Yes, scared of change. It's a normal human emotion.
Yeah, exactly.
Right? Until you figure
it's
out that the change.
uncomfortable.
Until you figure out the change is actually a good thing, right?
That's right.
It opens new doors for you. So
That's right.
for metal additive, materials is a big one. Exotic materials that might have been too expensive to get a whole block that you're going to take away from it, or even internal cooling channels and design freedoms of how that part's going to be used. So for metal additive, let's talk about whether it be laser powder bed fusion all the way to DED. It's opened it up because it's not the same parts. It is different. They're able to leverage certain material properties that they weren't able to easily do before.
That's so awesome. All right, so lastly, let's talk about what's new on the horizon from Siemens that you can tell us about. And I'm sure we can find out more at your booth if you're here at Automate.
For sure.
But for those watching at home, tell us what we can get excited about.
There's a lot of new flexibility pieces with Siemens. Whether it be using AI to help you program controls, whether it be a more flexible programming piece as you as an engineer. We're talking about a lot of different products that we're showcasing today that actually for additive makes it easier for startups and machine builders to adapt an industrial grade, ruggedized product into their system. So that's pretty cool, and I'd love to talk to anybody that wants to talk about those things, but the one thing I'll highlight is we are showcasing a robot that is doing very high accuracy, path-dependent, high variability situations. So it might be milling, but with additive, sometimes milling and whatever your deposition extrusion head might be interacting. And we're had a lot of interest over Automate about what Siemens has done with these different players. So.
It's very exciting to see and hear about. Zach, you're so passionate about this topic. You clearly love the work that you do. Why is additive manufacturing a really exciting industry to work in right now?
Because it's always new. It's not, we approached that 30 years ago and this is how we solved it. It's, no, we're trying something brand new about, melt pool monitoring that no one's ever tried to apply before. Let's really whiteboard it and think about how to approach it. I am an engineer. I was a mechanical engineer in university and everything. Yeah. And problem solving is what excites me and gets me out of bed every day, right?
Yeah,
so now with an additive manufacturing industry, you're actually problem solving. Not to say the other ones aren't problem solving.
I'm sure the problems are, solved in easier and bigger ways. It's almost like just your ability to be creative about how to solve the problem.
Yes, more flexibility. Yeah. You don't have to approach it one single way. It's, wow, there's probably 4 ways to approach this. Which one is going to be the best?
Right. That's so cool. All right. Well, Zach, it's been really fun to have you here this morning talking about the cool work that Siemens is doing in 3D printing. Like I said, if you want to check more out, Siemens has got an incredible booth here on the Automate show floor. Zach and his many colleagues will be there to give you a demo. Be sure to check out Siemens' website as well to learn more about what they can do for you and your 3D printing needs. Thank you so much for being here on this episode of Automate Live.
Thank you.
had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information, that association, to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital, the people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole.
All right, welcome back, everyone. We are here at Automate Live. I'm Jake Hall, the manufacturing millennial, continuing to interview some incredible people and hear their stories about what's happening in the automation, robotics, and industrial community. I'm here with Charlie Norris, who is the Senior Product Manager of Wago. Charlie, how you doing today?
I'm fantastic. How are you doing?
I'm doing wonderful. So the relationship with Wago goes back many, many, many years. Yeah. I started as a distributor for you guys back in 2013.
Okay.
And sold your product for many years, and you guys have a lot of cool technology that you guys are showcasing on. So for the audience who's not familiar with Wago, can you give us a background of who Wago is as a company?
For sure. We're really known for our as cage clamps. We developed the cage clamp connector to help or to eliminate loose wiring and interconnection. So we have a whole line of terminal blocks and 221s we're famous for electrical wiring. But over the last decade, we've been expanding into automation. So we have a full line of PLC controllers, Ethernet switches, HMIs that also all use that spring cage technology inside of them.
Yes.
And then all of our platform, we program with Codis' software, so make it really easy for our customers to switch from one platform to the other platform. They don't have to learn a new software, or they can import-export code from one platform to the other. So
absolutely.
Yeah.
So I mean, a lot of amazing product lines that Wago's had. So, I always remember you guys from the wire nuts and all that stuff, and of course all of the internal components that go inside of a panel. But I want to dive more into this automation platform that you guys are pushing out recently, and really making it so it's not just devices that are always inside the panel or communication that's happening just inside the panel. Can you talk more about the automation platform at Wago?
Yeah, the automation platform, we have both IP20 that you're going to put in the control panel. We have IP67 as well for remote I/O. And we've got kind of now a platform from fixed I/O controllers to flexible I/O. We're known for having slice I/O that customers can pick the I/O that they need and just put it on a DIN rail and away they go. So it makes it really easy to design a system right for whatever I/O combination that you need. And we have a lot of specialty modules, things like a 3-phase power measurement module where you can measure energy consumption, phase angle, harmonics, right, to help people get a handle on energy usage and to help them optimize it.
For sure. The one thing that, as the industry is changing, I've seen more and more technology coming from Wago over the past few years. So it's not just, PLCs that you guys are doing running on Codis, but you guys are also talking about and pushing more on the edge controller side as well. Can you talk more about what that solution looks like?
Yeah, we're seeing a lot of customers, of course, here at Automate. You see it all over, right? People trying to collect data from their plant floor, and then they want to analyze that data, and really the whole goal in the end is really to optimize their process, right, and make sure they're running most optimally. So a lot of people don't want to do that on PLC because it takes a lot of resources at the PLC level. So we have our edge devices that can collect data. It can do analytics. A lot of times you may want to compress that data. You don't want to send all your data to the cloud because it gets kind of expensive, but you can send a lot of the contextualized data up to the cloud to get that real good view of what's happening on the platform or on your plant floor.
So let's dive more into the analytics and data side that's happening on automation, right? I think for a long time, the PLC was just a controller that was making machines run. But now all of a sudden, we want to understand better, what does productivity mean? What does production over time mean? How efficient are our operators? Could you dive into why we're seeing a trend from manufacturers when it comes to pulling more analytics and data from these machines?
Yeah, I think it's really, we're living in a smaller and smaller world, right? Competition is really tough in the manufacturing world, so a lot of our customers are looking for ways, finding ways to optimize, right? And they need to do that. And, we're helping customers even on our PLC level. We support a protocol called MQTT right in our PLCs. So if you want to send data right to a cloud, that's a preferred protocol for doing that, and so give that data right to a cloud if you wish, or a SCADA system, right? But we're also seeing people use these edge controllers right in the middle as well.
And what industries do you see using these controllers? Where are you seeing your solutions being installed today?
We're seeing a lot on the factory floor, right? People are installing. They have legacy systems where they need to collect that data, and that's I think a big market for it. We're also seeing a lot of things in, I would say, the energy industry, and things like around renewable energy microgrids are being very popular, right? So you got to collect the data from those platforms as well. So that's kind of an expanding market and a kind of exciting new market that we're moving into.
So when you look at, you talked about brownfield facilities, right? It was going in and it was connecting to devices on a aging platform that they want to pull analytics from now. Where do you see companies struggling the most with when it comes to maybe misconceptions around how difficult it might be to get data, or not understanding, hey, I don't need to completely change out or upgrade my entire control system to begin to collect information on my floor.
Yeah, I mean, the old adage, right? If it works, don't fix it, right? So you don't want to go on your legacy equipment and start changing something that has been working for you for years. So a lot of our customers are using a PLC controller with I/O on board. They'll connect to things like the stack light, or maybe grab some temperatures or RPMs or on their platform, right? And the machine, that their legacy machine, still doing what they're doing, but they're adding this onto it to collect that data. Right. And that way you don't have to change the PLC program to find tags or whatever you need to do. You can just collect it without touching anything on your platform.
And the big thing I look at it too, of a lot of cases, is you don't have to worry about downtime. If you can go out here and you can grab data in parallel of a production system, you're not going to shut down lines for weeks and months at a time. You can go out there, you can grab the data, and then you can begin to access analytics real time and begin to make decisions that on that data. It's one of those things, you're not just collecting data, you can actually make actionable decisions that are going to make change.
Yeah, for sure. And we're seeing, we used to have operators on the plant floor. Now we have connected workers, right? So the people on the plant floor need that information in near real time, right? To see what's going on the line upstream of where they're working or downstream of where they're working, right? And so a lot of our HMIs have these tools in as well. So not only just sending data northbound, you want to send data southbound to give the connected worker a lot of information about what's happening on the plant floor and how they can adjust, right? Give them that information to make intelligent decisions.
Absolutely. So let's talk about one of the newer products that you guys are pushing. You're putting you're just recently launched the DER controller from Wago. Can you dive more into that? How did that come to market? Like, what was the reason you guys wanted to bring this technology there?
Yeah, I think it's an interesting technology. And the DER controller is really focused on, DER stands for Distributed Energy Resource. So that could be a solar field, a wind plant, or a microgrid. And as these become more and more prevalent, right, there had to be a way for a grid operator, that's your utility, right, to integrate with these devices, interface with these devices to make sure you have the right power coming on the grid. And these devices can really help improve grid, right? They can help things like voltage sag, they can boost up voltage, of course, obviously add a lot of energy on the platform as well. It's rather new. There's a new standard. It's called IEEE 1547, which is this integration standard of how to communicate the DER with the utility. And so we've launched our DER controller that meets the requirements of 1547. So it makes it a lot easier for an owner of a DER solar field or microgrid to put this install this. They know it meets the 1547 platform, right? And it can talk with a grid. Usually a grid owner, usually a DMP3 protocol is pretty popular here in the States.
And I think it just goes back to, right, when regardless of what industry that we're in or what application, data and being able to then make actionable data, like we just talked about in the previous conversation, like what we're doing here with the DER controller is getting data. If it's in the renewable energies or a solar farm, or if it's on your manufacturing floor, it could even be, a solar farm that's on top of a manufacturing building.
Right.
There's a lot of different applications that are being done. So I want to dive into next about, we have IoT in a box.
Yeah,
that's another one. So let's talk about IoT in a box. It's expanding, I would assume, on data collection and a really easy form factor, right?
Yeah, correct. So you mentioned before, people have legacy systems and how do I collect that data, right? So we're trying our IoT in a box is to make that much easier for a customer to install an enclosure. They connect to like a stack light or an energy source, right, to measure energy. And then through just configuration using a web browser, they can configure what those inputs are. And then this device then will send that data up to a cloud where you can get analytics off of it. And you don't have to be a programmer to do it. You don't need to know PLC code. You don't need to know C code. Right? It's all done through configuration. So it's a much easier way to get someone started by collecting data off their plant floor without having to be a expert in PLCs.
Absolutely. I think it's one of those things that we always look at. How do we make collecting data and getting information easy for the manufacturer. Because a lot of times it can be intimidating. It could be systems that are 20, 30, 40 years old. You might not have a controls engineer that's on house that knows how to connect things, but you want to understand what is some productivity that I'm doing? What are my energy consumptions? How often is my air compressor turning on and off? As we know, compressed air is a very big power consumption within a manufacturing facility. Do I have leaks running throughout the night when I am not running anything yet? My generator is still kicking on and off every 35 minutes.
Yeah,
That's all applications that IoT in the box could use.
Yeah, and absolutely you can, and then you start monitoring that, like, oh, my compressor's running faster and faster, or turning on more and more often, over time, like, oh, we probably do have leaks somewhere, so you can go track those down and save energy.
Absolutely, or going out there and hooking up to some of your large horsepower motors, where you want to go out there and you want to know, hey, am I getting a little wobble? What's happening? And it's preventative maintenance, it's real-time analytics, and it just goes to show how important collecting data is for manufacturers.
Yeah, absolutely.
So when we look at the general industry, with the few minutes that we have left, what do you see the industry moving in the next few years ahead of time? And then what is WAGO most excited about when it comes to those industry trends?
Yeah, I think I think it's all around collecting data, right?
Yeah.
That's where everything's going, like we just talked about. So I think the next step really is we have to find easy ways for analytics to get that data to the right people at the right time, and get that real-time information. And then, as I mentioned before, it's also have to send that data back down to the plant so the connected worker can make those real-time decisions. So I think that's just going to expand over the next several years, and it's just going to become more and more important. So that's one area we're looking at. We also think that the energy market, especially with renewable energy and the electrification of automobiles, right, is also going to add a lot of challenges. So we're working on products to fit in that market space as well to help users manage energy. But here again, it's all about data, collecting data, how much energy you have available, what kind of vehicle you have, or how many vehicles that you have. So those are all kind of exciting new things coming down the road.
Absolutely. So you guys are also showcasing here at Automate.
Yeah.
What new technologies that we talked about do you guys have in your booth that people can come in, stop by, take a look at? What do you want them to see?
Yeah, we have our whole portfolio of automation products showing in our booth today, and we have our IP67 platform, and we have a simulator for our DER controller. So
awesome.
Come on by.
Fantastic. Well, Charlie, if people want to learn more about WAGO and they're not able to check it out here at Automate, where should they go?
It's easy. Just find us on our webpage. It's wago.com/US. Bring you right there.
Fantastic. Well, Charlie Norris, Senior Product Manager of WAGO, really appreciate your time. Love talking about mobile, the IoT in a box, the DER controller, edge controllers, the new technology that you're bringing to bring data into the hands of a lot of manufacturers and end users. We really appreciate your time.
All right. Thank you.
Awesome.
Thanks for the opportunity.
Absolutely. Well, if you guys want to stay tuned, we're going to have some more interviews and conversations coming up shortly. But have a great day at Automate Live.
has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information, that association, to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital of people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole. A3 has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information, that association, to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital of people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole. has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information, that association, to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital, the people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole. has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information, that association, to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital, the people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole. has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information, that association, to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital of people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole. has had a huge impact on the automation industry, and I benefited through my company, General Motors, who used that information, that association, to further develop and advance robotics technology. A3 brought together all of the different supplier companies which could deliver the technology. The human capital of people that knew how they operated and could work with them, and it had a big positive impact on the success of General Motors, and clearly it had a big positive impact on many other companies and the industry as a whole.